Of all the phenomenons in the universe, black holes stand out as truly extraordinary. Black holes are areas in space where matter is so tightly packed that nothing, not even light, can escape them. Because the normal rules of physics break down within them, it's easy to consider black holes as something only found in science fiction. Yet, there's plenty of evidence that they really do exist in the universe. Here are 5 ways we know that black holes are real. Number 5. Gamma-ray bursts. In the 1930s, Indian astrophysicists studied what happens to a star when it has used up all its nuclear fuel. The end result, he found, depends on the star's mass. If that star is really big, say 20 solar masses, then its dense core, which may itself be 3 or more times the mass of the Sun, collapses all the way down to a black hole. The final core collapse happens incredibly quickly, in a matter of seconds, and it releases a tremendous amount of energy, in the form of a gamma-ray burst. This burst can radiate as much energy into space as an ordinary star emits in its entire lifetime. And telescopes on Earth have detected many of these bursts, some of which come from galaxies billions of light-years away from Earth. So we can actually see black holes being born. Number 4. Invisible companion. The high-energy events that produce gamma-ray bursts and gravitational waves may be visible halfway across the observable universe, but for most of their lives black holes, by their very nature, will be almost undetectable. The fact that they don't emit any light or other radiation means they could be lurking in our cosmic neighborhood, without astronomers being aware of it. There's one sure-shot way to detect these dark monsters, and that's through their gravitational effects on other stars. While studying a pair of stars that were orbiting each other, astronomers noticed some strange behaviors in their motion. These behaviors could only be explained if there was an unseen third object present in the system. When they worked out its mass, the researchers knew there was only one possibility left. It had to be a black hole. This black hole was the closest black hole yet discovered. It was 1,000 light-years away, inside our own galaxy. Number 3. Supermassive black holes. In addition to black holes created through stellar collapse, evidence suggests that supermassive black holes, each even billions of solar masses, have been lurking in the centers of galaxies since the early universe. In the case of so-called active galaxies, the evidence for these heavyweights is spectacular. According to NASA, the central black holes in these galaxies are surrounded by accretion disks that produce intense radiation at all wavelengths of light. We also have evidence that our own galaxy has a black hole at its center. We can see the stars in that region move at incredibly high speeds, reaching up to 8% the speed of light. This suggests that they are orbiting an object that is both extremely small and incredibly massive. Current estimates put the Milky Way's central black hole somewhere around 4 million solar masses. Number 2. Spaghettification. Another piece of evidence for the existence of black holes is spaghettification. You might wonder, what is spaghettification? It's what happens when you fall into a black hole, and it's pretty self-explanatory. You get stretched out into thin strands by the black hole's extreme gravitational pull. Luckily, that's not likely to happen to you or anyone you know, but it may well be the fate of a star that wanders too close to a supermassive black hole. In October 2020, astronomers witnessed this shredding from a helpless star as it was ripped apart. Fortunately, the spaghettifying didn't happen anywhere near Earth. It happened in a galaxy 215 million light-years away. Number 1. A direct image. So far, we've had plenty of compelling indirect evidence for black holes, like bursts of radiation or dynamical effects on other bodies, that couldn't have been produced by any other object known to science. But the final clincher came in April 2019, in the form of a direct image of a supermassive black hole at the center of Messier 87 galaxy. This stunning photo was taken by the Event Horizon Telescope, which consists of a large network of telescopes scattered all over the world, rather than a single instrument. According to NASA, the more telescopes that can participate, and the more widely spaced they are, the better the final image quality. The result clearly shows the dark shadow of a black hole, against the orange glow of its surrounding accretion disk.